Assalamualaikum YouTube viewers. The topic of today's video is Geiger Muller counter. So I'm going to explain what really are the Geiger Muller counters. So a common gas ionization counter is a Geiger Muller counter. Okay, this is the counter that is used to measure the radioactivity of our sample. So now first of all, moving on towards the diagram. The diagram, as you can see here, that the chamber here, the wall of this chamber is actually a cathode. Okay, and this wire inside is the anode. This wire inside is the anode. Okay, and the radiations come inside the chamber through this window. Okay, and this cathode and this anode are connected to a battery. Okay, so now moving back, a common gas ionization counter is the Geiger Muller counter. In fact, it is also an ionization chamber. Okay, it is also an ionization chamber in which the cathode is cylindrical and a thin tungsten wire fixed along the axis of cylinder tube shell serves as a node. So what we have here is that a Geiger Muller counter consists of an ionization chamber in which the cathode is of cylinder, as I've just shown you earlier, that the cathode is a cylindrical and anode is a wire. Okay, so moving on, radiation enters the tube through the thin window made of mica. The radiation enters the tube through a thin window made of mica. Okay, as I've just shown you earlier that radiation enters through the window. Okay, so now a working potential of about 1200 volts is applied between the inner wire and the other tube and the outer tube. Okay, how much potential is applied? Potential is applied of 1200 volts. When ionizing radiation enters through the mica window, it interacts with the filled gas to produce positive ions and electrons. Okay, the ionizing radiation, when it comes through the window inside this chamber, it will interact with the argon or whatever the gas present inside the chamber. The incoming radiation will interact with the gas present inside the chamber and will produce the ions. Okay, and the next thing we have the positive argon ions. If we have the argon gas inside the chamber, the positive argon ions move towards the cathode, whereas the electron will move towards the anode. Okay, so the counter generates a pulse. So due to the movement of this argon ion and due to the movement of the electrons, there will be a pulse generated by the counter, and the application and the amplification of the pulse from each ionization causes a clicking sound in the loudspeaker. Okay, so this is connected, so this arrangement is connected to an amplifier. Okay, and the amplifier is further connected to a loudspeaker which produce a clicking sound with each pulse. Okay, or activates a digital counter that registers the amount of radiation entering the tube. Okay, so now this amplifier can be attached to a loudspeaker. This amplifier can be attached to a loudspeaker, or this amplifier can be attached to a digital counter that registers the amount of radiation entering the tube. Okay, so now a chart recorder may also be attached to the circuit to give a graphic display of the intensity of radiation versus time. Okay, so it can also be attached to a chart recorder. So the last thing we have is that this counter is generally employed for the detection of beta and gamma rays, although its modified form could be used for particles, protons, neutrons and X-ray photons. So that was all for Geiger Muller counter, and moving on towards its merits. This technique is very sensitive. Okay, and it produces a large pulse which requires no further amplification. And the last thing is the pulse size is independent of the nature of incident radiation. No matter which radiation you use, the pulse size is actually independent of the nature of the incoming radiation. Okay, and the limitations, it is very sensitive for high counting rate. Actually, this is very sensitive for high counting rates. And the last thing, it is unstable to give information about the nature of particle detected. The Geiger Muller counter cannot give us any information about the nature of the particle that is detected. Means it cannot give us the information about the nature of the incoming radiation. Okay, so now moving on towards the scintillator. This will be explained in the next video. Do not forget to like the video and subscribe the channel. Thank you and Allah Hafiz.